Hey YouTube, it's the Blue Lawnmower here, and for our first and possibly only video today, unfortunately, I was trying to record another video earlier today, and my software decided it wasn't okay to record audio for that video. So yeah, it might be the only video today, unfortunately. But yeah, let's make the most of this, since it might be our only video today. Alright, so you see Earth here. This, obviously, is the mass of one Earth. Oh, something I forgot to say. No one commented on last video. I didn't expect them to. But if you guys have any suggestions on something I should do in this game, be sure to let me know by commenting in the comments. And yeah, so what we are going to be doing today is steadily increasing Earth's mass until there is no chance that life could exist on our planet. And yeah, if you don't know what mass is, think about weight. It's not exactly lightweight, because weight is determined by gravity, but it's like how much, I believe it's like matter, like how much space it takes up. So this takes up the mass of one Earth. This takes up the space that one Earth does, obviously, because it is Earth. Anyway, we are going to steadily increase this. You can see our life likelihood just shot down. We are going to steadily increase this until everything is dead. The crust is getting colder due to it's getting further away from the surface. You see, do we have any snow in unusual places yet? Oh, another thing. I am not feeling great. I might sound a little dusty in this episode, I guess you could say. But yeah, I went on a trip and I was around humans, and yeah. So while it was daytime there, I saw snow in Africa. And when there's snow in Africa, you know you've done something wrong. And that we have done here, ladies and gentlemen. We have most definitely done irrational things that we should not have done. And I am getting messages on Steam that I will have to respond to later because I am recording. Alright, 6 Earths. 7 Earths. If you don't know where the life likelihood is, it's right there. So be sure to keep an eye on it just to see when we're done. 8. 9. And you might be wondering why I'm going so fast. It's because if we were to go at a super slow pace, then this would be the entire episode. And I know you guys don't want to watch an entire episode worth of me just screwing with Earth's mass. So yeah, we're going 10. Now, since we're at 10, we're always just going to increase the first number by 1. So now that we're at 10, 20 Earths. Let's do it. Alright, so now around a little over 1 billion people have died. And here on this Earth, this expanded Earth, you would weigh 20 times your normal weight, meaning I would weigh around 2,000 pounds, which would be hard for me to carry. It'd be hard for anyone to carry themselves, really. Alright, 40. 50. Oh, look at all the snow in Africa now. We have done all of the wrong things. 60. 70. 80. 90. 100. 200. 300. 400. And we are the biggest planet in our solar system now. We are the mass of 1.26 Jupiters. And our life likelihood, only 48% of living things on Earth are still around. Alright, let's go up to 2 Jupiters now. 3, 4, 5, 6. Come on. Where is it? Where's Mass? Alright, there it is. 7, 8, 9, 10, 20. Whoa! What did we just do? Did we just... Our life, like, some things are still around, but they're dying off. We're a gas giant now, guys. I didn't know you could just automatically become a gas giant with enough mass. We don't even have any hydrogen. I guess our Earth is mostly made out of silicate. Did that evaporate? I feel like it did. It had to have, right? It had to have. But yeah, our life likelihood is going down pretty quickly. 30, 40, 50, and all life on Earth is now extinct. We'd probably suffocate from... Oh, we're lighting up. That's what we're doing. One, we're probably suffocating from all the gas silicate in the atmosphere. And 2, we're extremely heavy. Let's see. Jupiter is somewhere around 300 Earths. So that means we would be around like 150,000, I think. 150,000 times our own weight. So yeah, that's probably way too heavy for anything to live at that point. But yeah. Alright, next up on our list of things to do, we're going to go back to Earth and basically, hang on, let me slow this all down so we can get a good view on it. Basically, we're going to do the same exact thing, but in reverse. Alright, now we're the mass of 40 moons. I just seriously decreased our mass. I just cut our mass in half. Life likelihood has gone down because weight is having the opposite effect that it did. Meaning that now we weigh only half of our normal weight. So someone would like me would only weigh like 60 some pounds. So yeah, less than that actually, now that I think about it. So we're 40.6 moons. We're going to drop to 20 moons. See what happens there. So also, with the lack of weight comes the lack of gravity, which means that we could jump 4 times higher than you normally could. It'd be almost like living on Mars. Our gravity is less than a third, actually. Mars's gravity is about a third of Earth's. So this is, we're smaller than Mars right now. And lights are still there. But anything not nailed to the ground has started kind of drifting off. But now we got 10 moons on our hands. Let's see what happens there. I'm going a lot slower since with getting smaller, I assume things will start to happen a lot faster. 5 moons. Alright. 3 moons. A lot of everything has melted away. The poles have gotten colder. For whatever reason, when I expanded it, the poles got warmer. That's interesting. The poles got colder, but everything near the equator got warmer. And then when we got bigger, things near the equator got colder, and then the poles got warmer. Huh. That's interesting. I don't know why it does that. Anyway, 2 moons. Oh, see that? The poles just expanded their territory. The mass of the moon. Oh, we got oceans evaporating. We got oceans evaporating, ladies and gentlemen. The poles have maintained due to the fact that they're getting colder. I don't understand why it does that. If you have any clue, be sure to leave a comment explaining why, because now I'm curious. But we've already eradicated life on Earth, because we've already eradicated all the water, or liquid water actually. Nope, it's actually legitimately completely evaporated off of the Earth's surface. Well, that's a thing. Well, alright. Now, do you remember, like, I think it was last episode. Do you remember last episode, back when we took Pluto, we set it in terms of the sun, got rid of that, and set it to, I believe we set it to, wow, why did you do that? We set it to like 10 suns. We're going to see what happens when we set it to 15,000 suns. Oh my gosh. So, yep, that's a supernova. We want it to get big enough to the point where it causes every kind of black hole. Yeah, I don't want the supernova to get, like, evil in the way of everything. So we're going to set it to terms of the sun. And make the mass go up even more. Let's try 30,000 times the mass of the sun. Yo, look at that. you can still kind of make it out from here. Wow, alright, that's massive. Still not massive enough for us, though. 60,000. Not there yet. 120,000. 240,000. Nope, not 200, 240. Yeah, now it's massive. You can kind of even make out the 48,000, 96,000, 960,000. Let's just go for 1 million. 2 million. How big must this be? That! Oh! That's what happens there. Hang on. It probably didn't have any kind of effect, though. Yet. So we can probably save our stuff. Alright, there we go. Yep, everything's safe. Nothing just died, don't worry. Alright, now we got ourselves a black hole. Now that's big enough to become a black hole. So now, oh wow, look at it distorting light around it. Now, we're going to watch this kill the entire solar system. Just a second. Oh my gosh, why did that happen? Whoa, why is it giving off that glow? It's hurting my eyes, honestly. Hang on, let me get out of this so I don't have to deal with the fact that it's a nova. Because that's kind of annoying. To be completely honest, I don't want that. I don't want anything to do with that. Okay? Alright, come on. 3 million, come on, please. Oh wow, it set me far back. Oh, I set it to 3 million kilograms. Whoops, that's the thing. That's much less than Pluto's weight. Or mass, I'm sorry. That was stupid of me. Alright, we're going to set to terms of the sun this time. Now, 3 million. Yeah, 3 million. Please? Oh my gosh. This is so huge. So big. Right. 4 million. 5 million. I've seen evidence that it becomes a black hole somewhere along this path. I just got to figure out where along. Nope, that's not what I meant. Okay, we're just going. $8 million. 9 million. 10 million. 11. No. We're not. What is, no, that's not how numbers work, Dylan. You're drunk. No, yeah, it is. Oh my gosh, I'm more drunk than I thought. Alright. I'm just waiting for this to become a black hole, honestly. 50 million. 60 million. 70 million. I forgot what a 70 was. What is a Oh my gosh. I just realized how big that thing is. That's huge. $90 million. 100 million. Alright, now we got this black hole going. Oh, please don't tell me it's about to become a supernova. I see that thing, which means it's about to become a supernova, huh? Yup. Look at that glow! That's so huge. Well, now we know the mass we have to set it to. So that's good. We'll set it to terms of the sun. 100 million. There we go. Now we just got a normal old black hole in the middle of the solar system. You can see it from way out here. That's crazy. Alright, so what we're going to do before we start this thing back up, we're going to go here, look at Earth's climate. So, yeah, everything looks normal right now, but that's because I haven't unpaused it. We're going to watch how this affects the solar system, and how fast it does it, and how Earth's climate ends up. Oh, okay. That happened very swiftly. That happened extremely swiftly. Alright, we're just flying off into space with everything else, aren't we? Yup! Our surface temperature is dropping not nearly as fast as it probably should be. Now, let me pause this. Alright, you can definitely tell a lot of the surface is frozen. Frozen? Frozen! That's how English works, kids. Alright. Oh, it's because of the sun. This is because the sun is kind of close. I mean, I guess. Is it going to get sucked into the sun's orbit again, maybe? Is that something that happens or not really? Is this trajectory just too great? Nope. The sun's not dealing with that. No. Is it? I can't tell. Earth's frozen over as it is right now. No, the sun's leaving it. Bye-bye. Alright. Well, I'm going to end this video here, guys. Hope you guys enjoyed. And I will see you guys later. What was that?